Hello everyone, my name is Rupali Ramchandra Barde. I am studying in B.Sc. second year, Adarsh College, Hingoli. Welcome to all in today's online seminar. Today I am presenting partial differential equation. Partial differential equations are those equations which contains partial differential coefficients, independent variable and dependent variable is called partial differential equation, in which the independent variable will be denoted by x and y and the dependent variable denoted by z. Partial differential coefficients are denoted by del z by del x equals to p, del z by del y equals to q, del square into z divided by del into x square equals to r, del square into z divided by del x into del y equals to x, yes, del square into z divided by del into y square equals to t. Method of forming partial differential equation. A partial differential equation is formed by two methods. First, by eliminating arbitrary constant, and second, by eliminating arbitrary function. We take one example on by eliminating arbitrary constant. Z equals to x plus a into y plus b, in which a and b are the arbitrary constant. Equation 1 differentiate partially with respect to x. Del z by del x equals to y plus b into 1. Because we differentiate partially with respect to x, therefore y plus b is constant and derivative of x is 1 and a is constant, therefore their derivative is 0. And del z by del x is the partial differential coefficient and it denoted by p, therefore p equals to y plus b. Equation 1 differentiate partially with respect to y, therefore del z by del y equals to x plus a into 1. We differentiate partially with respect to y, therefore x plus a is constant and derivative of y is 1 and b is constant, therefore their derivative is 0. And del z by del y is a partial differential coefficient and is denoted by q, therefore q equals to x plus a. The solution is z equals to p into q. We take another example in which we eliminate the arbitrary function. Z equals to f of x square minus y square. Equation 1 differentiate partially with respect to x. Therefore, del z by del x equals to f dash of x square minus y square into 2x. We differentiate partially with respect to x. Therefore, y square is constant and derivative of x square is 2x. And del z by del x is the partial differential coefficient and is denoted by p. Therefore, p equals to 2x f dash of x square minus y square. Equation 1 differentiate partially with respect to y. Therefore, del z by del y equals to f dash of x square minus y square into minus 2y. We differentiate partially with respect to y. Therefore, x square is the constant and derivative of y square is 2y and we get minus y square, therefore their derivative is minus 2y. And del z by del y is the partial differential coefficient and is denoted by q, therefore q equals to minus 2y f dash of x square minus y square. P by Q equals to 2x f dash of x square minus y square divided by minus 2y f dash of x square minus y square, in which 2 and f dash of x square minus y square is get cancelled. Therefore, P by Q equals to minus x by y. P into y equals to minus qx, and the solution is py plus qx equals to 0. Thank you.